In this section, you're going to learn how to add notifications to your apps. So we're going to take our app to the next level and implement the ability to send a message to the owner of a listing. This will send a push notification to the target mobile device. So let's jump in and get started. When it comes to sending push notifications, we have a few options. We have Expo's push notification service, which is the best and simplest solution for Expo applications because it hides all the complexity from us so we can send and receive notifications in just a few minutes. It works in both managed and bare React Native projects and is free at the time of recording this. The other options are OneSignal, Firebase Cloud Messaging, and Amazon Simple Notification Service. To use any of these services, you have to eject from Expo because you have to make a number of changes to the native projects. To be honest, the setup is a bit painful. I'm not a fan. In my opinion, Expo's push notification service is by far the best. Once you finish this section, just look at the documentation of any of these providers and see how much extra work you have to do to set up notifications. And it's not just that. The problem is that if you miss any of these steps or don't execute them properly, your notifications are not going to work. Then you will have to come back and review every single step. It's just so painful. So my recommendation is to use Expo unless you work in an organization and there is some policy in place that says you have to use Amazon. So that's all about providers. Next, we're going to talk about how notifications work. To use push notifications, first we have to use Redux. No, I'm joking. We don't need to use Redux here. There are 4 steps we need to follow. First, we need to register our app with Expo to get a push notification token. This token is a long string that uniquely identifies each device. So with this token, we can send a notification to a particular device. Next, we need to store the token in a database on the server. So somewhere we have a table or a collection of users. Each user can have properties like ID, name, email, and Expo push notification token. With this token, we can send a notification to a particular user or a group of users who match some criteria. So the third step is sending a notification, which often happens on the server. For example, let's say we're going to contact this guy about his red jacket. So somewhere on this screen, we should have an input field for sending a message. When the user taps on the send button, we're going to send the message to the server. On the server, first we're going to store the message in a database, and then we're going to notify the target user. That's where sending notifications happens, not on the client, not in the app. And finally, the last step is handling received notifications. This is where we decide what to do when the user taps on a notification. All these steps are super easy to implement, so next we're going to work on the first step. To implement notifications, we're going to use the Notifications API in Expo. As you can see over here, this API is not supported in Android Emulator and iOS Simulator, so the only way to test this functionality is using a real device, okay? Now look at the installation instructions. This API is pre-installed in managed apps, so we simply import notifications from Expo. But for bare React Native apps, you have to make a number of changes to the native projects. Just look at this README file for all those instructions. Now, here in app.js, if the user is logged in, we render the app navigator. Otherwise, we render the auth navigator. Now, in this implementation, we want to get a notification token only when the user is logged in, because we want to associate these tokens with our user objects, okay? So let's go to App Navigator. On the top, we're going to import notifications from Expo. We should also import the permissions module because first we have to get the user's permission. So import everything as permissions from Expo-permissions. Now, look at this function component. Here we're simply returning this JSX expression. We need to write some code here, so let's add a block of code. In this block, we return this JSX expression. Now, let's add the right brace, save the changes. Our code is reformatted. Beautiful. So let's create a function called register for push notifications. This is going to be an async function. Here we should use the permissions module to get the user's permission. So we call permissions.askAsync. The type of permission is permissions.notifications. We await the call to get the permission object. Then we check if permission is not granted. If it's not granted, we're going to return immediately. Now, when you test this on an iOS simulator or an Android emulator, this property always returns false, even if you give permissions, okay? Next, to get a push notification token, we're going to call notifications.getExpo push token async. We await the call to get a token. Now, for this demo, let's just log the token on the console. So, console.log token. Now, we should wrap this code inside the try-catch block in case something goes wrong while getting this token. So, let's add a try-catch block and move all this code up here. Good. In the catch block, we're going to log an error saying error getting a push token. And here's the actual error. So here's our function. Now we're going to call this using the effect hook. So that's going to be the first thing here. Use effect. We pass a function. And here we call register for push notifications. And we want this to be called only once, okay? So here in Metro Bundler, I'm going to point my phone's camera on the QR code to load it on my phone. Okay, the app is loaded on my phone, and here's my Expo push notification token. So it's a long string that uniquely identifies each device. Well, more accurately, it uniquely identifies each app install. So if I reinstall this app, I'm going to get a new push token. Otherwise, every time I load the app, I will get the same push token. Okay, so we've gotten the push token. The next step is to send this to the server and store it in our user object. We'll do that next. Now we need to store the push token on the server. So we have this endpoint, Expo push tokens. This is a protected API endpoint, so we need to pass the auth token in the request header. And in the body of the request, we should pass a JSON object that includes our push token. Now, if we send a post request to this endpoint, we get a 201 response. And in the terminal for our backend project, we see this message, user registered for notifications. And here's my user object. So you can see my user ID, name, email, password, and Expo push token. So this is purely for testing. So this is how I've implemented this endpoint. In your backend, you might have an endpoint for updating a user using a put or a patch request. That's the implementation of the backend, which is irrelevant in this course. So now in our frontend project, let's extend our API layer and implement the ability to register a push token. So here in the API folder, let's add a new file called expo push tokens.js. First, we import the client module. Then we define a function called register, which takes a push token. And here we call client.post to /expo push tokens. Now in the body of the request, we're going to add an object with a single property called token. We set this to push token. Now our client module automatically includes the authentication token in the request header, so we don't have to worry about it. So finally, let's export a default object with the register method. We're done here. Now we go back to our app navigator.js. Instead of logging this token on the console, we're going to send it to the server. So on the top, first we're going to import expo push tokens API from, we go up to API /expo push tokens. And finally, here we're going to call expo push tokens API.register token. Now we don't need to await the call because we don't have to wait for the response to do something after. We just call the server and this happens in the background. So save the changes. Okay, you can see we have a new registration. So I'm successfully registered to receive push notifications. Expo has a fantastic tool for sending test notifications during development. So head over to expo.io/notifications. We can fill out this form to send a test notification. So here's my Expo push token. Here we can supply a title for our message, like Mosh says. For the body, we can say, is your jacket still available? Now here we can optionally include a JSON object in the message. This is useful for sending listing ID or other properties that we will use when consuming this message. Now in this demo, I want to pass an object with a special property. So first we add quotes. The name of the property is underline display in foreground. We set this to true so we can see the notification when the app is open and in foreground. If you don't set this to true, you're not going to see the notification. This is by design, okay? So for iOS, we can supply a couple of additional properties like subtitle and batch count. We can also play a sound. And for Android, we have this channel ID. I'm not entirely sure what these channels are because I'm not an Android user. So let's send a test notification. Perfect. So here's our notification. Next, I'm going to show you how to send this in code. To send a push notification, you need to use one of the SDKs provided by Expo. So on Expo documentation, go to guides and then push notifications. Here you can see various SDKs for sending push notifications. We have implementations for Node, Python, Ruby, and other languages and platforms. So depending on what you're using to build your backend, you need to use one of these SDKs. They're perfectly documented. You wouldn't have any problems using them. Now, in terms of what happens under the hood, this image perfectly demonstrates what happens when you send a push notification using one of these SDKs. So here's your backend. When you send a message, an HTTP post request is sent to Expo backend. Now, Expo gets the message, and depending on the type of the target device, it routes the message through one of these two channels. If the target device is an Android phone, Expo sends the message through Firebase Cloud Messaging Platform. Otherwise, if it's iOS, it sends the message to APNS, which is short for Apple Push Notification Service. As simple as that. So all this complexity is hidden from us. All we have to do is to send a message using one of the Expo SDKs. Now, in our backend project, you can see my implementation in this file, push notifications inside the utilities folder. So here I'm using Expo Server SDK, and I've exported a function called send push notification, which takes a push token and a message. Now, the implementation is really simple. It's very similar to what you see on the documentation. Now let's talk about handling received notifications. So here in App Navigator, we're going to register a listener that will be called every time the user taps on a notification. So we say notifications.add listener. Here we pass a listener function that takes a notification object. For now, let's just log it on the console. Now later, we're going to change this code and take the user to a particular screen. So save the changes. Now I'm going to send a notification. Okay, I'm going to tap on it. Here's our notification object. I'm not sure what action ID is, but look at data. This is the JSON object that we included with the notification. Now, origin can be either received or selected. If we receive the notification while we're in the app, origin is received, otherwise it's selected. So if the app is currently not in the foreground, we get the notification and tap on it, then origin is selected. Now, remote means this is a remote notification. We also have local notifications that I'm going to talk about later. So this is how we can handle received notifications. Now, quite often, when the user taps on a notification, we want to take them to a particular screen. And that's what I'm going to show you next. Quite often, when the user taps on a notification, we want to take them to a specific screen. So over here, instead of logging the notification on the console, let's add a block of code. And here we should use our navigation object to take the user to a different screen. However, in this component, we don't have access to the navigation prop because, as I told you before, this prop is only available to screen components. The components that we have registered as screens inside a navigator, like feed navigator here, okay? Now, app navigator is a root navigator component. So here we don't have access to the navigation prop. So delete. By the same token, here we cannot use the navigation hook. If we do this, we get a runtime error. So how can we access the navigation object? Well, there's a trick for it. Let me show you. We go to app.js. Here's our navigation container. We can create a reference object and associate it with this component. From that reference object, we can access the root navigation object. So here we type React.createRef. Let's call that navigation ref. And then we associate it with this container component. So we set ref to navigation ref. Now this object, as you know, has a property called current. With this, we can access our navigation object. So let's store that over here. Now we can call navigation.navigate to whatever. But there is a problem here. We're creating this navigation ref object inside our app component. So this is not accessible in App Navigator, right? So we need to move this somewhere central that we can use in both these modules. So in the navigation folder, let's add a new file called root navigation.js. Here we import React. Then we call React.createRef. We call this object navigation ref and export it so we can use it in multiple places. Now back to app.js. We don't need these 3 lines. We just need to import the navigation ref on the top. So import navigation ref from app/navigation/root navigation. Okay, we're done here. Now in App Navigator, we can also import navigation ref. But to call the navigate method, we have to access the current property. This is a bit ugly. So let's go to root navigation. Here we can define a function called navigate with 2 parameters, name and params. These are the parameters of the navigate method. In this function, we're going to call navigation ref.current.navigate and pass these arguments, name and params. Now, if we access the navigate method too early, this current property is going to return null because this reference object is going to get initialized when this navigation container is rendered. So here we should check if navigation ref.current is available. Then we're going to use its navigate method. Okay. Now there is a shorthand for writing this code. We can get rid of the if statement and use the null coalescing operator. So we prefix the dot with a question mark, and that means if this object is not null, then the navigate method is going to get called. Otherwise, nothing will happen. Okay. So we have a one-liner. Let's get rid of the braces. So here's our navigate function. Now we're going to export an object with the navigate method. Okay. Now back to App Navigator. Instead of navigation ref, we're going to import navigation from root navigation module. Now we can use this object just like a typical navigation object. Here we also have IntelliSense because we have explicitly exported the navigate method. So we call it and let's send the user to the account screen. Now in a real app, we can inspect the data property of the notification, and depending on what we have there, we can take the user to different screens and we can also supply additional parameters. But this is the foundation. Let's test our implementation. So I'm going to send a notification. Okay, I'm going to tap on it and I'm on the account screen. So we're done with the implementation of notifications, but our App Navigator component is polluted with the notification logic. So the details of requesting the user's permission, getting a token, and then sending it to the server are all implemented here. As I told you before, our UI components should be only responsible for presentation logic. So we should move all this notification logic to a custom hook that we can easily reuse in the future. So in the hooks folder, let's add a new file called useNotifications.js. Here we export a default function called useNotifications. Now we go back to App Navigator. We're going to move all the code here to our new hook. Next, we need to move our import statements. So back to App Navigator. On the top, we're going to move notifications and permissions. We should also import the effect hook. So import use effect from React. Good. Back to App Navigator. We no longer need the effect hook here. Next, we should move Expo Push Tokens API. So cut and paste it here. So here in the effect hook, first we register for push notifications, and then we add a listener. Now we don't want to hard code this particular implementation. Maybe in another app, we want to do something different when we receive a notification. So I'm going to remove this function and instead add a parameter here. Let's call that notification listener. Now we pass that over here. We can improve this code and check if notification listener exists. Then we add it as a listener. Maybe in another app, we don't want to do anything when we receive a notification. Okay, so we're done here. Now back to App Navigator, and here we use our notifications hook. As simple as that. In Expo, we have two types of notifications, remote and local. Remote notifications, also called push notifications, are what we have been talking about so far. They are sent by the Expo backend. Local notifications are created locally in the app. Let me show you how they work. So for this demo, I've cleaned up the code in the app component. Here we only have a button. When we tap on the button, we're going to see a notification. So on the top, we are importing notifications from Expo just like before. Now, in this function, this is the function that gets executed when we tap on the button, okay? So here we call notifications.present local notification async. Here we pass an object. We set the title to congratulations and body to your order was successfully placed. Next, we set data to an object. And here we set underline display in foreground to true. Otherwise, we're not going to see the notification on iOS. Now, if this starts to become repetitive, you can go to app.json and add a new key value pair here. The key is notification. We set this to an object. And in this object, we set iOS display in foreground to true. With this, we don't have to set this property every time we create a notification, okay? So this is the preferred approach. Now back in app.js, we don't need the data property anymore. So let's test our app. Now, unlike remote notifications, we can test local notifications in our simulator. So look, tap, and here's our notification. We can also schedule a local notification for the future. So here we have another method called schedule local notification async. As the first argument, we pass a notification object. And as the second argument, we pass a scheduling object. Here we can set the time to, let's say, we get the current date time. Now, we get the time component and add 2 seconds to it. So this notification is going to appear 2 seconds in the future. Take a look. So save. Now, tap 1, 2, and here's our notification. So this is how we can use local notifications. Let me quickly walk you through what I have done to implement this new feature. So in our API layer, we have a new module called messages. Here we have this function for sending a message to the server. This function takes two parameters, message and listing ID. So this listing ID represents a thread of conversation. We can send various messages to this thread, okay? So here we send a post request to this endpoint, and in the body of the request, we include the message and listing ID. Pretty straightforward. Now we have a new component called contact setter form, which takes a listing object. Now here we have a function for submitting the form. Here we pick the message field from the form and the reset form function from formIC. So the moment we submit the form, first we dismiss the keyboard, then we use our API to call the server. If there is an error, first we log the error and then display an alert to the user. Otherwise, we reset the form and show a local notification. Pretty simple, nothing new so far. Finally, in listing details screen, I've wrapped the entire screen inside a keyboard avoiding view component. Here I've set behavior and keyboard vertical offset props, exactly like what I told you in the PDF. And finally, here we have the context setter form, and here we're passing the listing. Very simple. So I thought there's really no need for me to type all this code and have you sit there and watch me. So we're done with this section. In the next section, we're going to talk about building and distributing our app. So I will see you there. We have reached the last section of the course. In this section, you will learn how to prepare and distribute your app to real devices. We'll talk about adding an icon, optimizing the assets and the JavaScript bundle, error reporting, managing configuration settings across different environments, and finally creating a build for iOS and Android. I will also show you how to submit the iOS app to the App Store. Unfortunately, I don't have this experience with Google Play Store, but the process should be similar. I've added a couple of links for you to read and figure this out on your own. Now let's jump in and get started. Before we can build and distribute our app, there are a number of things we need to do. First, we should give it a proper icon. This icon should be a PNG file, and it should be 1024 by 1024 pixels. Make sure the width and height are exactly the same. They are not even 1 pixel different, and don't use round corners, okay? So we supply our icon in this dimension and have Expo build service automatically generate the other sizes for us. And last, our icon should follow Apple and Android design guidelines. I've put a couple of links for you below this video to learn more about Apple and Android design guidelines. Also, below this video, you can find this beautiful icon for our app. It's a D, short for done with it. So just copy and paste this into the assets folder. Now let's go to app.json. Here you can see the path to our icon file. This is another benefit of using the managed workflow in Expo. With Expo, we can supply a single icon file and have Expo create various versions of this icon in different sizes for different platforms. If you eject from Expo, you have to manually set the icon and splash screen for each native project. It's not a big deal, it's not the end of the world, but using Expo is a lot easier. The next thing we need to do before building our app is to optimize the assets in our project. These assets are going to be bundled into our app when we build it for production. So we should include only the absolute essential assets here. Anything that should be immediately available when we start our app. If we include too many assets here, we're just going to increase the size of our app. So anything that is not essential should be downloaded later over the internet. For example, here we have couch.jpg. I gave you this image before we connected our app to the backend. We no longer need this file. So delete. Also, we don't need chair.jpg and jacket.jpg. So here are our essential assets. Now we need to optimize the size of these assets. So we go into terminal. First, we install a library called sharp-cli. With this library, we can reduce the size of our images. So npm install -g. Make sure to install this globally. Sharp-cli. All right, sharp-cli is installed. Now we run npx expo-optimize. This library uses sharp-cli behind the scene to reduce the size of these images without losing quality. So let's go. All right, take a look. Our assets are optimized. For each asset, you can see the number of kilobytes we have saved. So totally we have saved 128 kilobytes. Now this is not a lot for this app, but in your apps, you might save a significant amount of data. When we build our app, all our JavaScript code gets combined and minified into a bundle. Now, when we start our app, this bundle has to be loaded into memory and parsed by the JavaScript virtual machine on a mobile device. So the more code we have in this bundle, the longer it will take to load and parse our code. So as a best practice, when using third-party libraries, always check to see if there are more lightweight alternatives. Let me give you an example. So let's go to cache.js. Here we're using moment.js to calculate the difference between two time values. That is this line over here. This is the only place in our code where we're using moment.js. But moment.js has a lot more functionality. So by importing moment.js, we're bringing a lot of code we don't need. In this case, we can replace moment.js with a different library called data.js. So let's install data.js. All right, I'm using version 1.8.28. Now, before we use this library, let me show you a great extension that I discovered only a few days ago. So let's go to install extensions and search for import cost. With this extension, we can see the cost of our import statements. So let's install it. Now here you have to reload VS Code. Now back in cache.js, you can see the cost of this import statement. That is 250 kilobytes. When compressed, that is 70 kilobytes. Now compare this with importing data.js from data.js. The cost of this import statement is only 7 kilobytes. See the difference? So let's get rid of moment. Now we need to make a few small changes here. Instead of moment, we're going to call date.js. If we don't pass any arguments, this will return the current date time. Now here we should also replace moment with date.js. And finally, we need to replace minutes with minute. So for whatever you want to do, always check to see if there are more lightweight alternatives. Now, one more thing before we finish this lesson. How you import something from a library can also make a difference in your bundle size. Let me give you an example. So let's install Lodash. Now let's say we need the unique ID function in Lodash. I'm going to show you 3 ways to import this function. We can import underscore from Lodash. Our cost is 71 kilobytes. What if we import the unique ID function? Our cost is still 71 kilobytes, but some libraries like Lodash are split into smaller packages. So here we have a package called unique ID. From this package, we can import the unique ID function. Now look at our cost. It's only 2 kilobytes. So how you import something from a library can also make a difference in your bundle size. All right, we're done here. Let's remove this import statement and uninstall Lodash. Here in cache.js, if we catch an error, we log it on the console. Now this works during development, but when we build and distribute our app to app stores, this console is not available to us. That's where we need error reporting tools like Sentry and Bugsnag. There are many other tools out there, but Sentry and Bugsnag are the 2 most popular tools in this space. Sentry is great. I've talked about it in my React and Angular courses, but Bugsnag is a new tool that I discovered. It's amazing. It's a lot better than Sentry, and that's why it's a little bit more pricey. With Bugsnag, we can report handled or unhandled errors. We can also attach additional diagnostic data about our errors. We can identify our users so we know who encountered what errors, and we can also monitor our error rate across different releases. Let me show you how to use Bugsnag. First, head over to bugsnag.com and create a new account. Once you sign up, you're going to see a screen like this. Of course, the screen may change in the future, but the foundation is going to be the same. So here we should answer a few simple questions about our project. We have a mobile app built with React Native using Expo. Our app is called Done With It. Okay. Here we can invite collaborators. Let's not worry about it. Skip. Now the installation. To install Bugsnag, we need to copy this line and paste it in the terminal. With this, we can install and run Bugsnag CLI for Expo. So copy, paste it here. Here we should answer a few questions. The first question says, Bugsnag doesn't appear to be installed. Do you want to install it? Yes. The next question is about the version. We want to install the latest version. So we hit enter. You want to install this using npm. Of course, you can use yarn if you want. All right, now this is going to install bugsnag/expo. All right, the next question is about Bugsnag API key. You can find this key on this page over here. With this key, our app is going to be able to communicate with Bugsnag. So copy and paste it here. The next question is about changing app.js. So we need to add these 2 lines to app.js. We can add it manually, or we can have this CLI automatically add it for us. So let's select yes. And here's the last question. Do you want to automatically upload source maps to Bugsnag? If you upload source maps, we'll be able to look at our stack trace in production. So let's select yes. Good. Bugsnag is installed. Now let's go to app.js. So on the top, we have these two new lines. We are importing Bugsnag and starting it. Now this Bugsnag object has a method for sending an error to Bugsnag. But we don't want to call this method directly. We want to hide Bugsnag behind an abstraction, because tomorrow we may decide to use a different error reporting tool that is cheaper or has better features. So we don't want to use Bugsnag directly in our code. Let me show you how to hide this behind an abstraction. Here in the utility folder, let's add a new file called logger.js. So this is our logger service. Here we're going to import Bugsnag. So let's import it on the top. Next, we're going to define a function called log, which takes an error. In this function, we call bugsnag.notify and pass the error. Now, pretty much all these error reporting tools have a start method. So let's implement that here as well. Start as a function. Here we call bugsnag.start. Finally, let's export an object with these two methods, log and start. So this is the only place in our app where we talk to Bugsnag. This is the only place where we know what error reporting tool we use. Now back in app.js, we can remove these lines on the top and instead import our logger service. So import logger from app/utility/logger. Next we call logger.start. Now to test that everything works, here in app component, I'm going to call logger.log and pass an error object. Let's say error in app. Save. All right, here's our app. Let's reload it. Okay. And here in the terminal, you can see Bugsnag is loaded and we're sending an error to Bugsnag. Now, if you look at your dashboard on Bugsnag, you can see the error. So let's have a quick look. So over here, we can see where in the code this error occurred. Currently, we don't have source maps, so we see the error in the final bundle. This is hard for debugging. Now look at this note. No source map applied. Source maps are not applied when running locally in dev or production mode. They're automatically uploaded for published builds. So when you publish your app in production, then you can see exactly where in the source code this error occurred. Now here we can see a bunch of data about the error. For example, we can see the device on which the error occurred. So this error occurred on an Apple simulator. We can see the version of iOS, as well as the version of React Native, Expo app, and Expo SDK. Very powerful. We also have the date and time of the error. Now we can assign these errors to various developers in our team and fix them over future releases. Here we also have the timeline view. We can see our error rate over a period of time. Very powerful. We also have releases. We can see various versions of our app and their stability score. This is a very comprehensive tool and covering it in detail is really beyond the scope of this course. So if you want to learn more, look at Bugsnag's documentation. Back to our project, let's remove this line from app component. Now we need to go to cache.js. Anywhere we are using console.log, we need to replace that line with logger.log. I'm not going to do that in this video because that's very repetitive and it's going to waste your time. So let's move on to the next lesson. For almost every app, we need to properly manage the settings for different environments like development, staging, and production. For example, in our client module, look at the base URL. This is only for development. When we build our app for production, we don't want to use this backend. We want to use the backend hosted in the cloud, right? So let me show you how to properly manage the settings for different environments. I'm going to copy this URL. Now, in the config folder, let's add a new file called settings.js. In this file, we're going to define all the settings across different environments. So we can create an object called settings. Here we can define the settings for our development environment. So let's set API URL to this URL. Now, let's duplicate this a couple times to define the settings for staging and production environments. For now, we're going to use the same URLs because we haven't deployed the backend anywhere else, okay? Now, depending on the current environment, we want to export one of these objects from this module. To do that, we go on the top and import constants from expo-constant. Next, we define a function called getCurrentSettings. In this function, first we need to see if we are in the development environment. To do that, we can use this global variable called dev. This is provided by React Native. So if we run our app locally, this variable returns true. In that case, we're going to return settings.dev. Now, if dev returns false, we are either in the staging or in the production environment. To detect that, we're going to use constant.manifest.release.channel. If this equals staging, then we're going to return settings.staging. But what is this release channel? Well, later I will show you that when we publish or build our app, we can build it for a particular release channel like staging or production. So let's keep going. If we get here, that means we're in the production environment. So we return settings.prod. Now, finally, we're going to export a default object here. We're going to call getCurrentSettings and return the value. Good. Now we go to our client module. On the top, we import settings from. We go up to config/settings and replace the base URL with settings.api URL. This is the proper way to manage configuration settings for different environments. Our app is ready for distribution. Now we have two options. We can publish it on Expo or build standalone binaries for iOS and Android. Publishing to Expo is great during development and testing. We can publish our app in a matter of seconds, and anyone in our team can run our app using Expo Client, even if they are located on the other side of the planet. This is much faster than building native binaries for iOS and Android. So here in the terminal, let's run Expo publish --release-channel. This is where we supply a release channel like staging. The name that we specify here is arbitrary. We can call it anything. If we pass staging here, constants.manifest.release-channel returns staging. So our app in Expo will be placed in the staging environment. So let's go ahead with publishing. All right, publishing is complete. The first time it takes a bit of time. On my machine, it took about a minute. But next time we publish, it's going to be much faster. So look at the project page. That's expo.io/our account/done with it. And here we have the release channel. So if you go to this URL, we're going to see this project page. Anyone in the world can open our app using this QR code. Now, if you have an app that is kind of a secret, you don't want other people to see it, you can change its privacy setting in app.json. So here in app.json, we can set the privacy setting to the default setting is unlisted, which hides your app from search results. So only people who have the URL can access your app. We also have public, which makes your app entirely public. And in the future, Expo is going to support private. I'm not entirely sure how this is going to work, but you can read about it on the documentation when it's ready. Next, we're going to talk about building standalone apps. So publishing to Expo is great, but we should use it only for development and testing because we don't want our users to download Expo Client to use our app. So over the next couple of videos, I'm going to show you how to build standalone binaries that can be submitted to app stores. To do that, we're going to use Expo's build service. This service is exceptional. I absolutely love it. We just run a command in the terminal, then sit back and wait for Expo to do all the magic. Now, as you can see on this page on Expo's documentation, this service is currently only available in the managed workflow. They're planning to bring this to the bare workflow in the future. I'm not sure when that's going to happen. So if you eject, you will have to build the app manually. And quite honestly, I don't recommend that. There's so many things you need to set up. The process is so complicated. Also, to build for iOS, you need to have a Mac. But if you use Expo's build service, you can have Expo's Mac computers create the iOS build for you. So next, I'm going to show you how to build the iOS app. To build an iOS app, you need to register in the Apple Developer Program. So head over to developer.apple.com/programs. You can enroll here. You can enroll as an individual or as an organization. Either way, you need to provide some documents to prove your identity. For example, if you sign up as an individual, you need to send them your driver's license so they can verify you. This process may take a day or two, but sometimes it happens faster. You also need to pay $99 per year. Your membership must be active if you want to distribute your app to the App Store or if you want to update it. If you don't want to update it, then you don't have to renew your membership. Your app will continue to sit in the App Store. Next, we need to go to app.json. And here in the iOS section, we need to add a couple of settings. The first one is bundle identifier. Make sure to spell it properly. We set this to a string that uniquely identifies our app in the App Store. By convention, we use the reverse DNS notation. So we can say com.codewithmosh.done with it. Of course, instead of code with Mosh, you need to add your own name because this bundle identifier should be unique in the App Store. So type an identifier and make sure not to change it in the future. Otherwise, things are not going to work. And by the way, this is just a string identifier. It doesn't mean you have to have a website up and running at this address, okay? The second setting is build number. We set that to 1.0.0. This build number is used internally in the App Store. Every time we release, we have to increase the build number. Otherwise, when we try to upload to the App Store, we'll get an error saying this build already exists. So we have this internal build number, but we also have this version up here, which is what the user sees, okay? So we add these two settings in the iOS section, save the changes. Now in the terminal, we run expo build:iOS. Here we should answer a few simple questions. The first question is about the build type. We have archive, which is for deploying the build to the store, and simulator for running the build on a simulator. We're going to go with archive. Okay, the next question is about your Apple account. So do you have access to the Apple account that will be used for submitting the app to the App Store? Yes. Next, we need to enter our Apple ID. So let's type our Apple ID and our password. All right, the next question is about Apple distribution certificate. Every developer can have one distribution certificate to submit apps to the App Store. Now here we're going to let Expo handle the process, so it will automatically create this certificate for you under the hood. This is much faster and easier than you doing it by hand. So let's go with that. So Expo created my distribution certificate on Apple servers. Now the next question is about Apple push notification key. With this key, we can send and receive push notifications. Again, we're going to let Expo handle the process. So let's go with that. The next question is about Apple provisioning profile. Every app on the App Store should have a provisioning profile. Once again, we're going to let Expo handle the process. It will automatically create this profile for us. So let's go with that. Okay, our build is queued up. We can monitor its status at this URL. Here's a page for monitoring our build status on Expo. As you see, our build just started. So back to the terminal, we can press Ctrl and C to exit. This will not cancel the build. We can still monitor our build at this URL. All right, our build is finished, as you can see over here. Let's download it. This gives us an IPA file. It's a package for uploading to App Store. Okay, here's the IPA file. As you can see, this package is fairly large in size. It's almost 200 megabytes, but this is not the size of our app in the App Store. That's going to be different. So when we upload this to the App Store, it's going to get smaller. I did a quick test before this video, and the size of the app was about 50 megabytes. But hey, we have a small app. Why is it 50 megabytes? Well, because by default, Expo includes a lot of APIs in this bundle, even if we don't use them. They're working to change this in the future, so only the APIs that we actually use will be included. But at the time of recording this, the only way to reduce the size of the app is by ejecting from Expo and building manually. Again, I don't recommend you to do this unless you know what you're doing. If you have built iOS apps before, then go for it, no problem. But remember, if you eject from Expo, you will lose a lot of power, a lot of simplicity. That's just my personal opinion. Do what works for you, but don't immediately eject from Expo merely because of the size of the app. Yes, size does matter, but it's not the only thing in the world. Now that we have an IPA package, we can submit it to the App Store for testing and production. First, we head over to appstoreconnect.apple.com and log in with our Apple ID. Now here on the dashboard, we go to My Apps and create a new app. Here we select the platforms on which the app is going to be available. This app is purely for iOS, so let's select that. We set its name to Done with it. Here we select the primary language, which is English. Next, we need to select a bundle ID. This is the bundle ID that Expo automatically created for us under the hood. Now for SKU, we need to supply a unique identifier for our app. So we can go with com.codewithmosh.done with it. We're done. Let's create the app. Next, we're going to use Transporter to upload our app to the App Store. You can get Transporter from the App Store. So install it and log in with your Apple ID. Then you're going to see the screen for uploading your app. So simply drag and drop the IPA here. All right, our app is ready for delivering. So let's deliver it. All right, this is going to take a few minutes, so I'm going to pause the recording. All right, our app is delivered to the App Store. So here on App Store Connect, let's go to our app. Now look at the Activity tab. Here you can see the first build of our app and its status. The processing usually takes about 20 to 30 minutes. Sometimes it happens faster, but sometimes it takes longer. If the build is stuck on processing for a long time, then you need to redeliver the app using Transporter. All right, my build finished processing. Now let's go to the Test Flight tab. With Test Flight, we can distribute our app to a small group of beta testers. So here's our build. Every time we upload a build, we see this warning, missing compliance. So click on this and provide export compliance information. So App Store Connect is asking if we use custom encryption in our app. If we do, then we'll have to provide extra legal documentation and go through a review of our encryption before being able to select a build. Here we are not using custom encryption, so we select no and start internal testing. All right, our app is ready to test. Now over here, we can go to App Store Connect users or add external testers. We can simply invite people by their email to test this app. So let's go to App Store Connect users. Here's my account. I'm going to select this and add myself as a tester. All right, it's saying one tester has been added to your App Store Connect users. We can also invite external testers. So here we can create a group. Let's say group 1 and add one or more testers to this group. So let's add a new tester. Here we can invite people by their email and add them as external testers. Now to test this app, these people have to download Test Flight. They have to get Test Flight from the App Store. And with Test Flight, they will be able to download and install our app on their iPhone. Once you're done with your testing phase and want to officially release your app, you need to submit it for review. So go to the App Store tab and then select Prepare for Submission. On this page, you need to provide a bunch of screenshots as well as some information about your app. You have to provide its promotional text, keywords, support URL, description, and so on. So you fill out this form and then submit your app for review. The review process usually takes about a day or two, so just wait until you get some feedback. If your app is approved, it will be live. Otherwise, you'll have to make the necessary changes and resubmit. Now, every time you want to resubmit, you have to increase the build number, create a build with Expo, and then upload it using Transporter. Now let's talk about building for Android. First, we go to app.json and add Android-specific configuration. There are two settings that we need to set here. The first one is package, which we set to a string that uniquely identifies our app in the Google Play Store. By convention, we use the reverse DNS notation. For example, we can say com.codewithmosh.done with it. This is just a string that uniquely identifies our app. It doesn't mean we have to have a website up and running at this address, okay? The second setting is version code. We set it to 1. This is the version of our app internally used in Google Play Store. We also have version up here. This is the version that users see. Okay, so every time we submit a new release, we have to increment version code. Save the changes. Now, here in the terminal, we run expo build :Android. Here we should answer a couple of questions. The first question is about the build type. We have APK for deploying to the store or installing directly on Android devices, and app bundle, which is an optimized bundle for the store. So if you want to distribute your app for production, you should use app bundle. But if you want to test it on your device, you should use APK. So here I'm going to go with APK. All right, the next question is about the key store. This key store is used for signing your app. If you know what it is and already have a key store, you can upload it here. But otherwise, let Expo take care of creating one for you. So here I'm going to go with one. Let Expo handle the process. All right, our build is queued up and we can monitor its status anytime by going to this URL. So we can stop this process by pressing Ctrl and C. Now let's go to this URL. Here's what we get. So our build is currently in the queue and it will start when one of the Expo machines will be free. Now, if this is too slow for you, you can upgrade to get priority builds. Let me show you how to do it. So on the top, we go to settings. Then on the left, we go to services. So here I'm using the community plan, which is free, but we have another plan for getting priority builds. I've tried it before. I loved it. All right, our build is finished. Now let's download it. Okay, here's the APK. Look at the size of this package. It's almost 50 megabytes. Why is it so big? Well, because by default, Expo includes a lot of APIs in this bundle, even if we don't use them. The Expo team is working to change this in the future, so only the APIs that we actually use will be included. But at the time of recording this, the only way to reduce the size of this app is by ejecting from Expo and building manually. Again, I don't recommend you to do this unless you know what you're doing. If you have built Android apps before, then go for it, no problem. But remember, if you eject from Expo, you will lose a lot of power, a lot of simplicity. That's just my personal opinion. Do what works for you, but don't immediately eject from Expo merely because of the size of the app. Yes, size does matter, but it's not the only thing in the world. Now back in the terminal, we need to download the key store that Expo generated for us. We will need the key store to publish new versions of our app. So every time we submit an update, we have to sign our app using the same key store. This is very important. If you lose the key store, you're not going to be able to update an existing app in the Google Play Store. You'll have to submit it as a new app signed with a new key store. So here we run expo fetch :Android key store. Okay, here's our key store credentials, and here's the path to key store. It's stored in our project folder under this name, donewithit.jks. It's right here. Keep this file somewhere safe. By default, it's excluded from Git, so you don't accidentally check it into your code repository. If you do, anyone who has access to this key store will be able to update your app on your behalf. You don't want that to happen. So keep this file and the credentials somewhere safe. From time to time, we need to update our app. Expo has this amazing feature called over-the-air updates. With this feature, we can update our app without going through app stores. So we don't have to create a new build and submit it to app stores for review. All we have to do is to publish a new version of our app to Expo. Anyone using our app, whether on iPhone or Android, will automatically get the latest version. So when our app starts, it automatically checks our project page on Expo to see if there is a newer version available. If it is, it will download it in the background and use it the next time our app starts. So the changes are not immediately visible. They're only visible when the app restarts. In the past, if we wanted to replace images or change some text or fix a bug, we would have to submit a new version of our app to app stores and wait for it to be approved. This is very time consuming. It can take hours or longer. With over-the-air updates, we just publish a new version of our app, and this can take only a few seconds. With this, we can easily replace assets, change text, fix bugs, and ship new minor features. For shipping major changes, it's best to increase the version of our app in app.json and submit a new build. Also, if we change any of these settings, like our icon, splash screen, Expo SDK version, and so on, we have to rebuild our app and resubmit it to app stores. So over-the-air updates are amazing. Previously, we could use them only in the managed workflow, but now we can also use them in the bare workflow. So we have reached the end of this course. I want to say thank you for allowing me to be your instructor. I had a lot of fun creating this course, and I hope you enjoyed it too. So now you should start thinking about your next app idea or apply for a job as a React Native developer. With what you have learned in this series, you should have a very strong foundation, and you should be able to discover new things on your own. So stay in touch with me. If you build an app or get a job, please send me a tweet and share your success story with me. It's the only thing that truly rewards my hard work. I want to know I have made an impact on you and your life. And finally, please support me by telling others about my coding school. I really appreciate your support. Once again, thank you, and I hope to see you again in my other courses.